Hey there, and welcome back to the Deep Dive. Great to be here. So we've got a really interesting set of source materials today, actually sent in by you, the listener.
Yeah, this looks good. It's exam prep stuff.
Exactly. Excerpts from a guide focusing on Dell PowerVault ME5 storage arrays, and importantly, how they link up with Microsoft Azure Stack HCI.
Okay. Practice questions, explanations. Sometimes the best details are hidden in those explanations.
That's the plan. Our mission here is to, cut through this technical info, pull out the really crucial insights, the stuff that helps if you're actually working with these systems or just trying to get your head around them.
So making sense of the core ideas. Storage, management, that hybrid cloud piece.
Precisely. Make it clear, make it useful for you. It's like a shortcut, really. Getting the essence without reading every single line yourself.
Got it. A distilled view.
Okay, then let's unpack this. We should probably start at the beginning, right? The foundational stuff.
Makes sense. Core storage, performance features of the PowerVault ME5 itself. The sources seem to jump right into that.
They do. And it's interesting how they immediately focus on, well, the essentials for a reliable system, things you just can't skip.
Absolutely. You need that baseline of safety and availability for your data.
So first up, protecting data at the drive level. The sources talk quite a bit about RAID 1. What's the key takeaway there?
Well, they explain it pretty clearly. RAID 1 is basically mirroring. You get an exact copy of your data on two separate drives.
Okay.
And the big benefit they highlight. For just those two drives, it gives you the highest level of redundancy.
Right.
Which is why, you see it often recommended for those really critical system volumes where data availability is crucial. One drive fails, the other one's still there with everything.
Makes sense. Simple redundancy. But then what about capturing data like at a specific moment? The sources bring up snapshots. These aren't exactly backups, are they?
No, not in the traditional sense. The source calls it a point-in-time copy of a volume, and they stress it happens almost instantly.
Almost instantly, okay.
Yeah, like freezing your data state, the practical uses mentioned, things like backup, testing, or reporting.
Right, so you could roll back fast or test and update against recent data, maybe.
Exactly. Or run a report without hitting your live system hard. The source says the main advantage is minimizing the impact on the production system's performance.
That speed and low impact, that's definitely a big deal. Okay, moving on. Performance, getting the most out of different types of drives in one system. The sources mention auto-tiering.
Ah, yes, auto-tiering. This is all about automatic optimization. The source describes it as dynamically moving data around.
How does that work, basically?
Well, the data you access a lot, the hot data, it gets shifted onto your faster storage tiers, think SSDs.
Okay.
And the less active stuff, the cold data, moves down to slower, maybe cheaper tiers like your traditional hard drives.
And the system just figures this out.
That's the idea. The benefit stated is it optimizes storage performance and efficiency without manual intervention. It puts the busy data where it runs fastest all on its own.
So just starting out, the sources give us these core pieces. RAID 1 for mirroring and protection.
Basic redundancy.
Snapshots for those quick point-in-time copies, giving you flexibility.
Right, for testing or quick recovery.
And then auto-tiering, letting the system itself optimize where data lives for better performance.
Exactly. These are like the fundamental building blocks you'd expect for performance and reliability in a modern array like the ME5.
Okay, solid foundation. Now, let's shift gears a bit. Features are one thing, but managing the system, keeping it running, knowing when things go wrong, that's crucial too. The sources cover these operational bits as well.
Yeah, this is where it moves into the admin's daily life, doesn't it? How you interact with the box, keep tabs on its health, deal with problems. It's all about uptime and making management, well, manageable.
Right. And probably the first thing you need is immediate notification if something bad happens. The sources mention alerts.
They do. They specifically call out email notifications as being commonly set up to shoot off alerts right away if there's a critical hardware failure.
Like a drive dying or something.
Exactly, or a power supply issue. The point, they say, is ensuring timely awareness and response. You don't want to find out hours or days later. You need that email now so you can act.
Makes sense. And if you do need to figure out what went wrong, or maybe Dell support needs info, the sources point to log collection. There's a specific command.
Yes, the save logs command. Sounds like the standard procedure for diagnosis. The source says it generates a comprehensive diagnostic log bundle.
So not just one file, but a whole package.
Seems so. Containing system events, errors, and configurations. And they explicitly state its purpose, essential for Dell support when troubleshooting complex issues. It's the data dump they'll need.
Okay. Sticking with that support theme, but more proactive, maybe. They also mentioned support assist.
Right, support assist. The sources frame this as a key part of Dell's proactive approach. It enables proactive monitoring and automatically creates support cases when it spots potential trouble.
So it calls home automatically.
Basically, yeah. The idea is it helps resolve problems faster because Dell gets notified, maybe even before you realize there's an issue brewing.
Interesting. Now, before you make big changes like firmware updates, upgrades, the sources stress a really important prerequisite.
Oh yeah, this is basic but critical system hygiene. Before a firmware upgrade, you must confirm all disk drives are online and healthy.
Why is that so crucial?
The reason given is simple: to ensure the hardware is stable, reducing the risk of upgrade failures. You don't want the upgrade itself to cause a bigger problem because a drive is already failing. Stability first.
Got it. Check the foundation before you build on it. What about just needing more space? Expansion.
Simple enough, according to the material. To increase raw capacity, you physically add an expansion enclosure.
So another box you plug in.
Pretty much. It houses additional drives, and connecting it just expands the overall storage pool available. More drives, more space.
And lastly, for this section, actually getting servers connected to the storage over the network, the sources mention connectivity, specifically ISCSI.
Right, ISCSI. It's super common. The sources define it as a protocol giving you block-level access to storage over standard Ethernet networks.
Block level, so it looks like a local drive to the server.
Essentially, yes. And the key advantage highlighted is that you can access this storage without specialized fiber channel infrastructure.
Ah, so you can use your regular network switches and cables.
Exactly, which can save a lot of cost and complexity compared to building out a separate fiber channel network.
Okay, so this whole management piece, instant alerts, good logs, proactive support like support assist, careful upgrade checks, adding expansion units, and using standard network protocols like ISCSI, it's all about keeping things running smoothly.
Yeah, making life easier for the admins and fixing problems faster, keeping that uptime high.
And one last piece, related to disaster recovery, perhaps. Data replication, specifically asynchronous replication.
Asynchronous. The source says this is good for disaster recovery when some data loss is acceptable.
Why only when some data loss is okay?
Because, as it explains, it replicates data with a delay to accommodate network latency between sites. There's a lag between writing data locally and it showing up at the DR site.
Ah, so it's not instantaneous.
Exactly, which makes it work better over long distances or slower network links. But it means in a disaster, you might lose the last few seconds or minutes of transactions that hadn't replicated yet, unlike synchronous, which waits for the remote write confirmation.
So, final thought then. What does all this actually mean? For how we should think about designing and managing these increasingly complex IT setups, where you've got powerful on-prem systems like the Power Vault talking to cloud platforms like Azure Stack HCI.
That's the big question, isn't it?
How does knowing these specific technical nuts and bolts, the replication methods, the management tools, the HA features, how does that shape your strategy for reliability, for making administration easier, and really getting the best out of both on-prem and cloud? Something to chew on after this deep dive.